Hey guys, Mrs. Traver here. We're going to work through our notes on graphing absolute value notes. So the game plan here is we're going to first think about a parent function, and that is going to be that of y equals the absolute value of x. We're going to get a table going here of some values, and then we'll get an idea of what this graph looks like. So let's start off with some points in the negatives and the positives. So let's do like -6, -4, -2, 0, 2, 4. We'll check those x's. Keep in mind that absolute value is a distance from 0. So anything that's under an absolute value is always going to become positive. So let's see, the distance that 6 is from 0 is 6 away. The distance -4 is away from 0 is 4 away. And you can see the pattern that's happening here. So let's go ahead and plot these points on the axis and see how that goes. All right, so as we can see, when we plot those points, we get this big wide V. This is going to be our parent function that we're going to refer back to. So we'll get used to that wording as a parent function, because we're going to refer back to it for every other one we graph, and we're going to talk about where our graph has changed from the parent function. So this is the parent, and you'll notice on my next examples, I've already plotted that line y equals absolute value of x. That's the black one in the middle there. So let's give ourselves another example here. Let's do the absolute value y equals absolute value of x plus 2. And we'll try our same x coordinates out front: -6, -4, -2, 0, 2, and 4. So if I put a -6 in for this x, if I substitute it in directly, and I've got the absolute value of -6 is 6, plus 2 more is 8. The absolute value of 4 is 4, plus 2 more is 6. Absolute value 2 is 2, plus 2 more is 4. And you can kind of start to see the pattern that's going on here. Absolute value, oops, where did I go wrong here? Absolute value 0, 2, absolute value 2, this should be a 4, whoops. And then absolute value of 4 is 4, and plus 2 more is 6, so it'll make a turn there. Go ahead and plot those points. All right, as you can see that this graph, when we plot it out and I extend it to the edges, it has just been shifted up 2. So when we're saying it shifted up 2, we're saying in relation to the parent function, it's shifted up 2, and this is called a translation. All right, let's try a different one. If I did y equals absolute value of x minus 3, we'll use our same x's. Go ahead and find your table, pause your screen, and check with mine. All right, here's our last one. Go ahead and check your table with mine. You should have 4, 2, 0, -2, 0, 2. And when I graphed this, notice it just dropped down 3. So this one shifted down 3. And that was also translation. So when we're adding or subtracting something on the outside of the absolute value, it moves with the y's. I think of the y's are on the outside and the numbers on the outside, so those go together. Let's look at the next example and compare it to our parent function. These ones are going to be a little different. Let's do the y equals the absolute value of x plus 2. And then the other one we're going to do is y equals the absolute value of x minus 3. All right, so let's check our tables out. Let's shift our table a little bit. Let's do -4, -2, 0, 2, 4, 6 for each of these. And then we're going to solve for our y. So if a -4 went in here, -4 plus 2 is -2, and the distance -2 is away from 0 is 2. If I plug a -2 in here, -2 plus 2 is 0. The distance 0 is away from 0 is 0. I put a 0 in here, 0 plus 2 is 2. Absolute value of 2 is 2. Put a 2 in, you get a 4. Put a 4 in, you get a 6. Put a 6 in, you get an 8. Let's go ahead and plot those. All right, looking at the graph of this one, it moved to the left 2 units, which I want to notice is maybe the opposite of what we would have assumed. There's a little bit of a plot twist there. Notice it says plus 2, you would assume plus would mean to the right, but it actually moved to the left. So what we've noticed here is 2 things. When we're adding or subtracting on the inside of the absolute value, it moves your x values, not your y's, so it goes left, right, not up, down. And also it goes the opposite of the way you'd expect. Let me show you that even further with the next example. Let's go ahead and find our values for the table here. -4 in here, -4 minus 3 is -7. The absolute value of -7 is 7. negative 2 in there. Negative 2 minus 3 is negative 5. Absolute value of negative 5 is 5. Put a 0 in. Absolute value of negative 3 is 3. Put a 2 in. Absolute value of negative 1 is 1. Put a 4 in. Absolute value of 1 is 1. I'm sorry. Put a 4 in. Oh, yep. Sorry, my bad. Put a 6 in. 6 minus 3 is 3. Absolute value is 3. So let's check these points and see what happens when we plot them. So for these, after we plot them, we've noticed that those move right 3. So again, when there's add subtract on the inside, it goes with the x's, and x's go left and right. It just goes the opposite of how you'd assume. So a minus 3 will move it to the right, and a plus 2 will move it to the left when it's on the inside. When it's on the outside, like our last example, it's on the outside, and so is the y. So those move with the y, and this one would just shift normally. So it went up 2 and went down 3. We just worked on translations here. There is the potential for a combination of translations, so I'm not going to go through these in this video, but so you have an idea that there's some more things out there. We could have an idea of something like this, where both things are happening at once. This negative 3 would have made it go down 3, and this positive 2 would have made it go left 2. So both those things are happening at the same time. We've also got the potential to reflect it. So if I had a negative on the out front, then instead of going like this, it'll change to go upside down. So it flips it. And then the last idea that I want to throw out there for you to think about is if I put a number out front, it makes it skinnier. So here's my parent function, y equals absolute value of x. This guy would be even skinnier. Similarly, if I put a fraction out front, compared to my parent function, this guy would be wider. So there's a few things going on here that we're going to leave for a different video, but this is a complex translation. This would be a reflection, and then this would be a dilation. Those are all things we'll work on some more when we do quadratics, but I will leave it from there. See you next time.